Hello, this is question 11 on your June 2018 paper 2 from AQA. And you have Ratti makes an open-topped cylindrical planters out of thin sheets of galvanized steel. She bends a rectangle of steel to make an open cylinder and welds the joint. And then she welds this cylinder to the circumference of a circular base. So we have this lateral sheet of steel and then the bottom one because it's open-topped. The planter must have this capacity, which is the volume, and welding is time-consuming. So Rakti wants the total length of weld to be a minimum. So think that you are welding this thing here, so in the connection, and here. Yeah, that will be the welding length. Calculate the radius and a height, age of a planter, which requires the minimum total length of weld. Justify your answer, giving them to an appropriate degree of accuracy. So we are going to find that length, and we are going to make it minimum differentiating. So that length is going to be this one, which is the height of the rectangle, so h, plus the length of the circumference, which is 2 pi r, plus 2 pi r. And we need to minimize this, and we need to minimize for this parameter of this parameter. So we have to find a way of eliminating one of them so we can differentiate with respect to one of them. We cannot differentiate with respect to both of them. So the other information that they give us is this one. The volume is 8,000 centimeters cubed. So I'm going to use the formula for the volume of a cylinder, which is area of the base, so pi r squared, times the height. This is going to be equal to 8,000. And from here, I can make h the subject and substitute here, or r the subject and substitute here. Yeah, it doesn't matter. I think it's easier, as this one is squared, to make h the subject. But you will get the same answer either way. So it's 8,000 divided by pi r squared. And I'm going to go with this expression, substitute here. That way I have L in terms only of R. So L is going to be H plus 2 pi R. Just substituting this one here, yeah? And now I can minimize or maximize my expression because I can differentiate. So I'm going to differentiate with respect to R, that is my parameter. If I decide here, make R the subject and substitute, I'm going to differentiate with respect to H. Yeah? So I'm going to write this in an easier way for you to differentiate. So R minus 2, and then it's very, very simple differentiation. So it's minus 2 times 8,000, which is minus 16,000, divided by pi, and then R2 one less, so minus 3. And then the second part, this one is just 2 pi. Derivative must be equal to 0 to have a stationary point. So that means I can simplify everything by 2. I only can do that. So this is 8,000, just to have slightly smaller numbers. So this is going to be equal to this. So I have that 8,000 r minus 3, or I'm going to write it again in the denominator, pi r cubed. So this one to the denominator, and then this minus goes positive because it's in the other side, and 8,000 is going to be equal to pi. Yeah, so I'm just reorganizing this equation, which means that r cubed is going to be 8,000 divided by pi squared, which means r is going to be cube root of that expression here. We get decimals, and they say round to an appropriate accurate, so I'm going accuracy. So r, if you do that cube root, you get 9.3238. I'm going to round, I don't know, 3 significant figures, so 9.32 centimeters through 3 significant figures. Yeah, so this radius is supposed to give me the minimum value, but I have to double check that is the minimum and it's not a maximum. So what I'm going to do is I'm going to differentiate a second time and see that my second derivative is positive, so I have a minimum and not a maximum. So if I differentiate this expression again, so I have we have that dl by dr was minus 8,000, so minus 8,000 divided by pi, r minus 3 plus 2 pi. I'm going to differentiate this again, so dl by dr is going to be minus 3 times minus 8,000 is positive 24,000. No, it's not 8,000, it's 16,000, sorry, 16,000, sorry. So this is 16,000. I had already simplified 16,000. When I multiply by minus 3, I have 48,000 divided by pi, and r to 1 less. And this one, the derivative is 0. And this value is positive for any value of r. Yeah, always positive, so I have a minimum. That's what I have to check, yeah, because I want the minimum length of welding. And the last thing I have to find is h, because they are asked me find the radius and the height, and I found the radius, so now I'm going to find the height. But I know an expression that gives me h in terms of r, so I can substitute this value of r in this height. So h, just to finish, h is 8,000 divided by pi r squared. So in this occasion, it's going to be 8,000 divided by pi. That value was 9.32 squared. I would keep the value in the calculator. This is 29.2918. And again, I'm going to round to 3 significant figures. 3 centimeters to 3 significant figures. And that's all with this question. We have found h, we have found the radius, and we have proved that it's minimum. Yeah, that's all.